What is up, guys? Welcome back to another Revit video. In this video, we're going to look at the type and instance properties of stairs. We've looked at a ton of different things with stairs already. We had just a basic intro. We just modeled stairs in general. And then we looked at modeling them by sketch, which, it's something, but it's another way of working with stairs. So I would highly recommend that you check out those few videos before you look at this one, because we're going to dive in a little bit deeper here. Okay. Getting into it now, I have just the basic stairs and a basic project template, nothing special. This is out of the box. This stair is out of the box. It's the most default thing you can get. I will say before we get into it, if you happen to learn something, please demolish that like button and subscribe. That really helps me out. Okay, the stairs. The first thing we want to look at is obviously the instance properties, because when I click on a particular stair, we have a ton of properties here. A lot may not be applicable to what you're trying to do, but let's look at the top here. We'll get to the type, of course, but the base level is by default level 1. The top is level 2. So we have options here of basically only choosing between levels for the base level here. I have the actual levels of my project, which are 1 and 2. And we can see here my levels are 1 and 2. And obviously by default, again, the stair will span between them. Besides that, we, of course, have the base offset. And this is literally how far above or below that base level do you want to begin. And in that case, it's 0. I'd recommend working 2 levels and not necessarily having these offsets baked in by instance properties, because you're going to get confused unless, of course, you have to maybe have a raised floor, maybe you have this or that. Obviously, if you have a raised floor, you might have like a concrete level and then an actual finished floor level, things like that. Things to be aware of, though. The difference with the top level is that we have a none option. So basically, I can say, well, I don't want a top constraint. I just want this thing to go a set distance. And by default, you'll see the desired stair height, now I have control over, will be equal to the level that it was at previously. In this case, level 2, the distance between level 1 and 2 was and still is 10 feet. If I now put that to none, that 10 feet will now appear at the desired stair height, and I can put that to 12 or 15, whatever it might be, and that's totally fine. The thing to be aware is if I change this, it's basically saying, hey, the top of the stair extends where you have the top of the stair modeled. And so if I press OK, nothing will happen unless I actually go back and address that, but the desired stair height will still be that 15. So just kind of know what's happening. It's going to ultimately fix things for you. So let's go back to 3D and change that, and we can see how the stair responds. See, nothing happens. And at that point, we'll have to address the stair, us wanting the stair at least to go to 15 feet within the stair itself. Of course, I want to put that back at 10 because that's a good default and just something to continue to work with. And in that case, I'm still going to put this at level 2. A lot of times if I have short stairs, I might have both the base and top level at 1. But you'll notice if I do this and don't move anything, and if I move my mouse cursor outside of these properties, I'll get an error. Right here, I hit an error, of course, because I can't have a 0 height stair. It doesn't make any sense. So it does default again to 10, but this will allow me to, maybe put in 3 if I have just a 3-foot short stair. Now, again, you'll have to edit the stair if you want to actually change that, of course. So putting this back to level 2, we can move down to dimensions. And the dimensions here are going to respond to the height that you have the stair set to, whether that's based on levels or not. So if I come here and put this at 10 feet, which means it's 10 feet higher or double the height, yes, we get the same warning saying the stair is not modeled high enough, but we have the desired number of risers. And this is set up to where it is responsive, but not only that, you can see I have an actual riser height, which is just a system parameter I don't have any control over, at least right here, but that's in the type properties, and we'll go ahead and show that here in a few minutes. But you'll see the default stair is a 7-inch max riser, which means that the desired number of risers is going to be based on the total height of the stair. Within the constraint of my actual riser height will have to be less than 7 inches, or at 7 inches max. And then my tread depth, obviously this is an instance parameter. I can change this to whatever I want if I'm working with different kinds of stairs. If it's a landscape, I would probably do this, but I wouldn't ever change this. I would try and change that in the type properties and work with something a bit different. Just kind of know that it's there. That's kind of why we're covering things here. I don't really like to deal with that. So this is interesting. we can see this is a built-in parameter that we do have control over, and it says tread riser start number. Basically, if I were to come to my level 1 and then I go to annotate, all the way at the right I can see I have this tread number, and if I decide to click on this particular run of stair, I will see the actual tread numbers. And I've never documented like this because I'm really working more commercial than residential. This is more of a residential thing from what I've seen. But if I click on the stair again, we can see tread riser start number. Maybe for some reason I want to start at 15. Well, then it simply starts at 15. I don't know why you'd want to do that. Obviously there are circumstances for wanting or needing to do that, but just know that it's there. That's really nice. So again, clicking on the stair, we can see we have the basic identity data. If we wanted to start scheduling these stairs, we can add a mark value. Again, comments, if we wanted to add images, if we wanted to point the contractor to a particular type of finish or something that we wanted in an image. I've never done that, but just know that it's there. And then the phasing. Obviously, if you are aware with what phasing is, you know what this is. It applies the same. And if you don't know what phasing is or how it works in a detailed manner, please do check out my phasing video. It's quite popular in a sense that it does give all the information, even though it is a bit long. Okay, we have looked at all of the instance properties. Now, I'm actually going to tab to select this single run of stair, and I can click on this. And we have yet more instance properties. And here we have the location line. And right now it is set to center, as if I were to draw a run of stair, I would draw from that center location. Now I can change this to exterior support left or right, or run left, run right. And you can see whenever I change this to exterior support left, nothing happens. And you can kind of treat this as if it were kind of the location of, if you're drawing a wall, whether it's the wall center line, the core, exterior, interior, or just the finish face, interior or exterior, things like that. So this applies more so when you're drawing the stair, which I covered in a previous video, but just know this is, if you were going to edit it, that's what would happen. So then here we have relative base height. And so the relative base height, again, we're talking about base and top here. The relative base height is 0 because we have it starting at 0. If I click off of this, you can see clicking on the whole stair, again, we have the base offset at 0 at level 1, of course. Looking at this particular run, we can see, yep, we start at level 1, which is 0, and then my relative height. And you can see here, this is, again, seeing that I have 9 risers here. You can do the math, that's under 7 inches. So this is my relative top height, or like the actual elevation above level 1 in this case, or wherever you have it above that start of the stair. Now, it looks like you can edit this, and let's say we put this at 6 feet. Now, I have the option of doing this, but this is going to totally break the stair in a sense that I have now edited that run to say, boom, I want this relative height to be at 6 feet. And if we look at this again in 3D, we can see obviously some issues here. I've added additional risers, and then my now relative height for the top of that run, it does not match my landing, of course, because they're at different relative heights. And you'll notice I didn't even get the 6 feet, because what I need to do, of course, is it's going to calculate that based on all of the type properties of stairs we're going to look at here in a few minutes. But just know that it's not going to give you exactly what you want unless you have set it up to do that. And that's based on increments of more or less based on the riser height that you set as the max. And by default, it's 7. So you can see here that my actual riser height is, it's less than 7, but it's not quite 7. Now, if I undo this, let's go back here to level 1, and if I select this run again, we could see my actual riser height is the same as it was as after I edited this. And that means it's going to adjust that and give you the height that you want based on the type properties of the stair. Okay, and then we have the actual run width, which is, I would suggest that you edit this when you're creating the stair. I'd try and make all the modeling of the stair consistent and correct based on what you're looking for whenever you're modeling the stair itself, because it's going to be difficult to come in here and try and edit these. And obviously, if you have to and you don't want to remodel the stair, totally fine. But like I said, we can come in here and change this to 4 feet, and it's going to increase the width. And that will be based on the location line. Just remember that too, of course. So maybe I need this to actually grow in. Well, I can have my location line be that exterior support left. And then if I have the actual run width set to 4, it's going to grow in. Cool. that's easy. Again, this is exactly like walls in a sense when it comes to that. Then the rest is all system parameters that are just reporting information based on all of the other data that you have or modeled the stair, that type of thing. We have the actual riser height. We have the actual tread depth, which again, we've set in the overall stair itself. And then this is really important. We have the actual number of risers and then the actual number of treads, that's really important. If you're going to be documenting this stair, you're going to have to document how many you have there, and whether you do it by plan here or both plan and section, which I typically do. I don't necessarily use these numbers, but I call the number of risers and treads out in plan and section. This is where you get that information. And these we'll look at in a future video when it comes to automating the documentation process in a slight fashion. Okay, so that has been the instance parameters of a run. Now let's look at just the basic instance parameters. If we tab to this landing and we click on this, we have the relative height again, and that's the only thing that we can address. We note that we cannot edit the phasing of particular runs or particular landings. That is reporting based on the entire stair. Just remember that that's something important too. The whole stair will have to be a separate phase, in its own separate phase. If you need to split a stair between one phase and another, you're going to have to not break the stair, but you'll have to model two separate stairs so you can have them in the appropriate phase. Okay, again, looking at the landing here, I can come to 3D, and if again we change this relative height of the landing to something like 6 feet, then everything, you'll notice what happened, and this is kind of ridiculous. The landing, because it is basically attached and responding to the runs, we decided to override that height, and that basically meant that all the runs associated to that landing were raised to that as well. And you'll notice again that relative height is not what we had expected it would be. This is 6'3", whatever, and we put in 6 feet. So again, it's responding to the number of risers. Also, if we come in here to level 1, you can see it actually responded to adding more risers, which is totally fine. In a sense, if that's what you want to do, basically to the point where I'm still coming from level 1, I just now have more risers to get up to that desired relative height, which means it got pushed out and things like that. So those are very important things to be aware of. So again, if we click on the stair after editing that, we could see, yeah, we still have this, all the same information is all the same. And look at here, let's go ahead and do this again in 3D, and we're gonna put this to like 2 feet. So you can see I'm basically moving the stair, and the stair runs are adjusting to based on the height of the landing that I place. So if you remember in the modeling video that we looked at for stairs, I have this adjustment that I can make to stairs in the edit stairs here. I can click on this run and I can move this, and it's going to push and pull how many treads I have on basically either side of this landing, which is a great tool, but just know that the relative height is going to change every time I do this, because obviously the height of the landing is going to change. And you can see here it's 4.5, and I move this again, and now it is 5.8. It's kind of interesting. So if you want to get pretty close to a landing at a certain height, you could totally model it that way, and the runs will respond in that regard, which is really cool. Interesting. I don't use that a ton, but I can see that using that in some places where I need to avoid an 80-inch head height, so that I don't have that issue. So I have more than that. So I could basically say, oh, I need to have this relative height of this landing at a particular elevation, and then have the runs respond to it accordingly. But also know that it is called relative elevation because that's just relative. The actual elevation will differ, of course, because of all of the other calculations. Okay, so we've looked at all the instance parameters of runs, the stair itself, the landing. Okay, cool. So let's move on now to type properties. And this is where things can get a bit crazy, but that's okay. I'll click on the whole stair itself. We'll go to edit type, and then suddenly we have tons of things here to look at. And so this is what I want to tell you about, and particularly to be careful with, and that is these calculation rules. If you're trying to meet code, just know that this is sort of to code. It kind of depends on what you're looking at. This is fine for residential. In most cases, this is fine for commercial as well, but definitely not the run width. Like the minimum run width you can set. A lot of times, and again, we'll look at a future video where we actually calculate let's say a commercial example of modeling a stair, if we do that, well, you'll probably not get a minimum run width of 3. But the problem with all this that I see is that I can put this even down to 1. And all of a sudden, I don't have a commercial grade stair. I hardly have a residential grade stair. Obviously, that's a bit different. So we have our max riser height and minimum tread depth. These are things I'm not wanting to change if I don't have to. But just know that this is where you would do that. And again, if you're going to do that, I'd probably duplicate this. And we would have another stair. We would make a new stair and do this. So I can put this at 6 inches if I want. Maybe if this is more of an exterior example, things like that. I don't know, that type of thing. But here, looking at the calculation rules, we have a lot here. So the stair calculator. This checkbox is off by default, and you can see the use stair calculator for slope calculation. And so basically, if I check this, I now have all of these different options to work with. And you can see here the results are used for stair creation only. They will not modify existing stairs. So just be aware, if you change this, it's not going to change existing stairs. It's for new stairs that you model. And we can see the basic calculation rule for this target slope is currently 2 times the rise. So 2 times the rise is, if we have a 6-inch rise, then that's a foot, plus 1. So 2 feet times the depth, whatever. And that's our 2 feet, 1 inch. Okay, and then the value range for valid calculation result. Okay, you can go crazy with this if you want. You can adjust these things if you want. Never in my entire life of working with Revit had I wanted to, needed to edit this at all. And so I would highly recommend that you don't do that. You just change these different parameters here because we're not trying to change certain slopes with stairs necessarily. You can achieve that in the easiest way possible by editing these calculation rules if you really need to. And again, I would avoid doing that if you can. Okay, moving down to the construction, we have this run type. And so again, the default here is this 2-inch tread, 1-inch nosing, 1/4-inch riser. Okay, you'll notice this is not just a setting or text or anything. It is another component. And now this is where things start to get crazy. And just kind of think about, if you're familiar with families, this is kind of like a nested family. We're loading a particular family into the stair itself or the stair run, and then we have the whole type properties of the actual stair, whole type properties of the stair, and then the particular type properties of the run. Just know that we're looking at the run here. So another way we can get to this is if I tab to this particular run, we were looking at all the instance properties before, but you can see, look, oh, here's that particular type, and I can edit that type, and then we are back here. So for the sake of this, I'm actually going to go back into the stair, edit the stair type, and then look at the run type. Okay, so if you ever need to change the materials of a stair, what you see and what gets reported as materials on stairs, we have it right here. And this is going to be in the actual runs. Remember that. The material and finishes, tread material, riser material, and then by default is nothing. I don't care. Most of the time, I don't bother doing this, but if you are making some sort of a monumental stair or something that's more than just a basic egress stair, you probably want to add some better looking materials here. Okay, then we have treads. So basically, do we have treads? Which is a bit of a silly thing to ask. Otherwise, we're not really working with a stair. Now, there have been some times where I've unchecked this and I don't have treads for some reason. I just have risers, and it's based on what you want to model and why and all this, whatever. But that's totally fine. We have a default tread thickness. Again, here's my 2-inch tread, and then again, my 1-inch nosing length, things like that. The nosing is what extends beyond that vertical riser portion. The stair nosing pan, again, we are looking at the nosing profile, and again, this is basically like another nested version. This is just a profile, and so I can look at these different profiles that I have in this default project, 2 of which will not make any sense for stairs, but you can, if you begin to understand what this is doing, this is giving you the profile for each individual stair, I guess you could say. And so if you have that knowledge in your head, you could do weird things with stairs. Like you could put weird profiles and have them continue up and down a stair. Like, I don't know why you'd want to do that, but it is what it is. And then it's like, where do we want to apply this nosing profile? And right here, it's to front only. Again, like the front of the stair. We can do a front and left, right. I mean, options here that I have never changed in my whole life because I typically only model in stairs here. And moving down, we have risers. And of course, this is kind of fun because maybe you have a more contemporary design stair, or specifically a stair that is in a residential setting, you might just simply turn the risers off. And if you do that, we have no options here to work with. If we have those options off, or the risers off, then we literally don't see risers. It's open through each individual tread. And that's cool. Just know if you're working in a commercial setting that if that stair is an egress stair, you will have to have risers. It has to be fully enclosed. So be aware of that, of course. And then we can choose to slant them. A lot of times you're going to have these risers slant back, so you have more of a tread depth and things like that. You don't have to have them necessarily at 90 degrees, but that's, again, more of a residential thing that I've seen before. And then we have a riser thickness. How thick is that riser? Typically, it's set this way just because it's probably a metal pan stair, and so the thin metal is going to continue here, and then you'll ultimately pour concrete on top of that metal pan. We have a riser profile. Again, this is where you can get kind of creative with the riser profile if you want to. I wouldn't recommend it. Just be aware of codes if you want to change it or need to. Riser to tread connection. So again, this is looking at the actual connection between my risers and treads. And the options here are extend riser behind tread. And then we have extend tread under riser. And then we can just join everything together. So I most of the time don't mess with this, but depending on the type of look I'm going for, I might end up changing that. Then we have the basic identity data that applies to essentially every Revit object here. Edit it, add it as you need to. If you want to look at scheduling and dealing with types of stairs and stair runs, this is where you would do it. Okay, so all of this is say, this is just the run of a stair. And as I change this, if I want to change it, I can duplicate this and adjust the types of runs. And the cool thing is that I would actually be able to change the look of the stair, only the stair runs. Okay, we've looked at the stair runs, cool. Coming down here, we have the landing type. And again, we're looking at a different type here. So if I come into here, we can say there's really not much to look at here. And so the basic option we have here is when it comes to treads, are they the same as the run? Is the tread of the landing going to act, look, appear, whatever, the same as the run? And again, this is something I have never changed in my whole life, just because I want, in 99 point forever number of cases, I want the landing to look like the risers. And that's just another example of something I've never changed. The function, I've never really, this is just like walls. You don't have to change this. This is not going to impact anything. But if you're looking to schedule stairs, schedule walls, based on the function, whether it's interior, exterior, then just kind of get this correct. That's totally up to you. Then supports. Supports are, it's kind of a beating. I will say supports are a bit of a beating, but think of them kind of like we were just looking at the stair runs. We've got the right support, and we have right and left, and then middle if we need it. We've got the right, and this is going to be a stringer close or a carriage open, like this type of thing. And I'm not going to go into creating a new support or anything like that. That's not necessarily the way we want to go about here. So using these default supports is totally fine, and then adjusting from there if you need to. And the actual support type, again, is going to be a different type. So looking at this particular stringer, it's called stringer 2 inches width. This is where I would want to change the different support. And I can obviously duplicate this if I want to. I call this example. This is where you would give the material to the stringer. Just know that once you're in the stair properties, type properties, you have to kind of root out into the individual pieces of the stair to add the materials. We've got our section profile again set to default. We can flip that if we have it modeled one way or the other. The structural depth on the run, we can change this, and this is just how high above the run the support goes. The structural depth on the landing, how deep below the landing it goes, the total depth, things like that, the width. This, obviously, if I wanted to change the width, make it a bit thinner, I would do that. This is just totally the way to do it. I'm not necessarily a fan of changing supports. Again, most of the time, I'm just working with basic egress stairs most of the time. But just note this is how you would do it. And then I have my left support, which is, again, I've set this to close. You can have them different. But then I've got my left type. I can change this now between the basic 2-inch that came with this stair, or I can put this back to my example that I just made. So we can see that you can use the same one for both the left and right. Then again, if most of the time you won't need a middle support, there are plenty of stairs, whether they're a certain width or whatnot, that you'll need a middle support. And in this case, we're looking at the same options that we had before. Do we want to use this 2-inch or not? And then again, this is a different type because it's not on either side, it's a middle. And then middle support number, basically what is the number and how many, that kind of thing. Okay, so I don't want middle supports. I most of the time will not need them. And then here we go, we have our cut mark type. So this is really weird to find in the Stair, but it is nice that it's here, and so just know that it is. Again, something that I really don't find myself changing, the cut mark type. Here we go, and the cut line type is going to be a single line, double line if you want. The cut line extension, the distance here, that this is basically what you see when you look at a plan. The cut mark symbol here is zigzag. You can have this curve, you can do however you want. So this is totally up to you. Most of the time, you're not going to need to or want to deal with that. And then finally, we have all the identity data that we're used to seeing with Stairs. So if I close out here, we can see, yep, there is my cut mark, and it's cool that it's kind of baked in there. You don't have to worry about trying to deal with that. It is within the Stair itself, so that's really nice. Okay, so what have we looked at? Well, we've looked at lots of instance properties and type properties for that matter when it comes to the Stair, to the point where we have looked at them all. And you can see here my supports are 1 inch as opposed to the thicker 2 inches. It is cool because I can simply tab over to the stringer and I can see exactly what it is. Well, this in fact is my 2-inch. So things like that, and it's very easy to add the material right there. So that is exciting. We have looked at essentially everything that we need to when it comes to that. And of course, I would be very wary with the calculations. Obviously, to code, we stick around because we will have another video coming out on Stairs in the future that will cover the specifics of calculating the width and everything, like basically the code of a stair, specifically an egress stair, of course, for a particular project, giving some occupancy examples and things like that. And I'll show you how I end up modeling it, and not only that, end up documenting that particular stair, because that's very important to be able to do. So we have looked at all the instance, which are a ton of different properties, as well as all the type properties for Stairs. So if you happen to learn something, please demolish that like button. It really, really helps me out a lot. Also consider subscribing, because that does as well. I will see you in the next Revit video. Have a wonderful day, and thank you very much for watching.